Well, hi, thanks for joining me in my shop this morning. Today is the 23rd of October. I've been out of the shop for a couple of days up in Ottawa during the Canadian election, which was just finished. So today, what I'm going to do, I have a very interesting idea that's been presented to me to alter the B plus level in this radio. Something my little brain would never have thought of, but it's led me to learn a whole bunch more, which I'm going to share with you about power supply filters. Maybe not a whole bunch more, but some more. But just before we get into that, yeah, here comes a sigh. So just looking at the amplifier for a minute, I'm just going to talk about it. I'm not suggesting that something has to be done or there is anything that can be done, but just highlighting a little more about how this amplifier's been fixed up or whatever. It started with me looking at the word speaker on here. So I thought this was the input transformer for these two tubes, but in fact it's the output. This is the output transformer going to the speaker. I checked the wiring underneath, it's definitely what it is. This is not original. There's no way this is original to this amplifier. And underneath, let me look underneath, these are the two input transformers here, or these act as output transformers for the 245s over yonder. Depends how you want to look at it. These are not original. These are not original. This is not original. Over here, I suspect this is not original. There's a input transformer up here. It's not original. The RF transformer up here has been changed. It's not original. What in heaven's name happened to this radio? How did it get all these things done to it? So I was kind of going on the assumption that most of this work was done around 1989 during its last professional shop visit. And now I wonder if in fact much of this work was done far earlier in the life of this radio. So if you think about it, from 1937 to let's just say 1957, that's 20 years. That's a long time. Now, this radio is basically in continuous use, as far as I understand it, right up until the modern times, into the 90s. So, wow. This is what happens to a heavily used radio as it tries to survive into the future. I still don't understand it. I've never seen a radio with so many major parts changed. I could understand maybe one of these being defective, but wow. And that raises a whole bunch of questions, especially with these transformers, which are not picked willy-nilly to go on these amplifiers. They are very carefully selected. The way the coils are built inside is critical. The resistance of them, the impedance of them is all critical stuff to make this operate. And surely to goodness, it's an unreasonable assumption that these transformers match electrically or electronically the ones that were in here originally. There's really not much reason to believe that. So this has implications with all kinds of things. Plate load, it just goes on and on. Tonal quality, current flow, everything. So anyway, I don't know what to do about it. I mean, I don't have a pile of these transformers. I wouldn't even attempt it. And besides, the whole thing works. Despite everything, the whole thing works. Just gets a little hot here and there. So let's switch topics now to the high B+. So I tried sneaking in some more resistors here to try to just basically burn off some of the B+. A little uncomfortable doing this. I don't know if I really spoke about it while I was doing it, because these resistors are replacing the field coil in the speaker, and in most radios this field coil acts as a choke in the positive part of the power supply. They're literally up here on this power supply. But here the field coil is in the negative return of the high voltage power supply, which is just a little different. Same current, I guess, going in and coming out, same current, but increasing the resistance of this is not having exactly the same effect that increasing the resistance up in the positive part of the power supply would have. In the back of my mind, I don't know if I said anything about it. I thought, oh my gosh, this might just be throwing off all kinds of bias things. This just may not be the right way to do it. And in the end, it didn't seem to have any real effect on the B+, which is definitely too high. So the first alternative I'm going to try here is to change the power supply from a capacitive input filter to an inductive input filter. A week ago I couldn't have even said that because I had no idea what I was talking about. But now I'm convinced I have an idea what I'm talking about. So here's what I'm going to do. It's really not very complicated. Thank you very much for my great mentor who sees when I'm not going to make it and offers help to get me there. So in a normal power supply, you have the output of the rectifier tube. I'm just going to start right there. So there you are, rectifier tube, output. Oh my gosh. Okay, this is going to be a little crude, but it's just getting across a basic message here. A little more light on it. Rectifier tube, B+ coming out of it, right? It's on its way, after being rectified, now it's on its way to the filter. Typical filters in radios are pi filters. Very typical. Capacitor. This is what I always call them. In many radios, an inductor. Right, and then another capacitor. These are the big electrolytic capacitors. A real simple version would look like that. It's a pi filter. This leading capacitor has a big effect on the output over here. The leading capacitor, as you picture the sine, well, it's no longer a sine wave, it's something like this coming at it. Something like that coming at it. This capacitor will try to charge up to this level. Okay, which is what, 1.4 times its RMS value. So the output of the transformer is 350 volts. The actual, and don't quote me on this, it's more complicated. I'm just trying to get through this really quick to indicate what's going to happen when I deal with this. The 350 is actually 1.4 times 350. The peak is actually a lot higher, maybe 420, somewhere up around there, 420. And this capacitor will try to charge up to that level, 420. And if it manages to do it, then you're going to get 420 less a little bit of voltage drop here. You're going to get, basically 420 out here, maybe 400. You get rid of this. Oh yes, so this is called a capacitive input filter because the input to the filter has a capacitor. First thing you encounter is capacitor. If we get rid of this, just get rid of it. Now we have an inductive input filter. Yes, we've lost some filtering capacitance here. Maybe we've got to make it up somewhere down here. The result now is this resistance knocks this down a little bit. And this capacitor will charge up to some lower value. Exactly what this works out to, the suggestion is, it's going to work out perfectly right. It's going to come out to what it's supposed to be. Now, if we look at the schematic here and ask, well, what did they actually design in this radio? Sorry, I'm just showing this like this. This is the capacitor we're talking about. Right ahead of the filter, look, it's got a couple of different choke filters in here. This capacitor, we just disconnect it, and this voltage should drop. Another thing worth noting too, which I really didn't pay close attention to, is if I do certain things in this area, I could potentially drop the B+ to the tubes out here, but leave it high on the 45s. The 45s are really worth protecting. Whoops, they're up here. They're really worth protecting. They're expensive tubes, they're rare, and the ones in here are in good shape. So we really need to make sure the B+ comes down on this. So removing the capacitor and dropping the entire power supply voltage will reduce these two. How much? We're going to find out. We're going to find out right now. We are going to find out. So We look for the wire that's coming from the rectifier. Here it is here. There's a Y splice floating here. One part goes to this capacitor over here. That's the input capacitor terminal. And the other part is going to this inductor. That's the input inductor. All I need to do is just pop this wire off the capacitor, turn the set on, and see what we get. Now there's a bit of a hum implication to doing this. Reducing the amount of capacitance in the filter system, if you like. And you can imagine it will just raise the hum level. For these resistors, I'm going to jump them out temporarily. Get them these ones I put in, and just leave the original, semi-original. These are also replacements here. 1,000 ohms here. That's what we'll do. So I'm going to set everything up for that. Voltmeters and everything. Then I mentioned I'm not feeling well today. Yeah, I came back with my granddaughter's cold, so I may go a little slow on this today. Okay, we're about ready to go here. Just pondering how to check for hum. I have the amplifier sitting right here, but the amplifier is not even plugged into its 120 volt power supply. I'm just making sure that the output transformers, which are down underneath down under the chassis here, are connected to the 45s over here. I'm not powering this up. I don't think that's critical in this, but I think when I alter this filter here, that a negative effect of it, a hum effect, may be audible in the output tubes, the 245s, but not earlier. And we're listening. We're going to start this test by listening earlier. We're going to be listening on the volume control back here. But maybe because of what I've done to the power supply, a hum is being introduced up here. We won't hear that first. So we hear no hum during this first test. It's not guaranteeing anything, but at least it's a good step in the right direction. So let's see, I've got the audio hooked up. I've got the voltmeter ready out of view of the camera. That's this voltmeter here. It's on the 500 volt scale. Previous measurements were 425 on this power supply. There is a note on this schematic. The number 325 shows up very close to the power supply. 240 is the voltage that should be on the plates of the 245s. And the rest of the tubes should be quite a bit less. Let's just take a quick look here and see if I can spot a voltage. No voltage written on these. Yeah, they didn't write. I thought, yeah, 225, 225, 226, 220. So 220 up here instead of the 350 I am getting now. Plus, we'll be starting this up with restricted power initially. That'll give us another chance to see if something really horrible is happening before it's too late. I just don't see that anything horrible can happen here. So we're connected to an outdoor antenna. I don't know what band we're on offhand, but let me check and see. We're on the AM broadcast band. I'm going to guess I left it actually tuned to a station, but using the wire outdoor antenna may not hear it. But we'll hear the hiss, and we're looking for the hum. It's the hum anyway. Okay, I'm going to don my headphones here and join you. Okay. Any reason not to power this guy up right now? It's been a few days since I've been in here, so I'm always a little bit hesitant here. But, unless the cats did something while my wife and I were in Ottawa, everything should be the same as it was. Here we go. Okay, so dim bulb's doing the right thing there. Grab my voltmeter. So we're going to look at the power supply voltage right close to the power supply itself here. So this is reading 200 now on this meter. I think we used to get a 350 reading there. Remember, the input voltage or the line voltage is only 100 volts. Ooh, something scurrying around on top of my bench there. Some kind of bug. Okay. So we'll look at what's up on the plate of one of these tubes up here. I'll just pick any one. It's pin 3, 1, 2, 3. Pin 3. And a little more light here. I can hear cats crying. Here we go. Pin 3. Okay, can you see the voltage there? Well, it's 200 on that meter. That's excellent. It should be under what it should be, and it is under what it should be. And now we're going to pop on. Oh, we got to listen to it. We got to listen to it. Okay, here we go. Well, I said, no, that's not a hum. That's what we're tuned into here. Well, there's a bit of a hum there, but it may have been there all along. No, that sounds great, actually. Okay, I think maybe this is going to work. So you put that capacitor, you use a capacitive input filter to get the most B plus out of it, but the regulation of the power supply isn't as good. So you can draw current, it may drop a little bit. With an inductive input filter, you get very solid voltage. The regulation is much higher. So I understand. Take everything I say with a grain of salt. Don't think it'll make one bit of difference here. Okay, so we're going to flip this up to 120 volts now and see what we're really getting here. Here we go. Okay, on the power supply. 250 on the power supply. 250, you can't quite see it there. You know, it's a long shot on the meter, but it's the 500 volt scale and it's coming straight up. 250. Up on the just any old tube up here. Just making sure again I get the right spot. Ah, it's right in the dark. Let's get in there. 1, 2, 3. Okay, and what does it say? It says 245 on my meter there, roughly 250, way down from 350. Bingo. Bingo. The supply voltage this morning is a little high, 123.6. This is not necessarily the supply voltage to my house. This is coming out of an isolation transformer, which may be altering the voltage slightly. So maybe it's boosting it slightly. 123 is a little high, so that's great actually, because tendency is this is going to be more likely 115 in somebody's house. Wow, you know what's next? What's next is how hot are those resistors getting? So I'm going to leave this baby running for a little while, and then we're going to check those resistors. Hot diggity dog. No, cold diggity dog. Okay, so the radio's only been on for 5 or 6 minutes here, but I'm going to have my thermal meter here. Wow, this thing is great. I have a lot of fun with this even in my house too. So we'll take the thermal viewer and we will now observe the hot transistor, which incidentally doesn't look like it's melting anymore. Here we go. Da, 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 da. A little hard for you to see that, eh? Let's see if I can make it a little better in the camera here. I'm going to take a good look and try to really get a feel for the temperature of these resistors. How does that work? Well, you're not really seeing what I'm seeing here. How can I make this a little better? I don't know offhand. Sometimes just getting the video light levels correct with all these things is just about impossible, but you can see enough to see that the resistor showing up on the screen there. And the temperature at this point, 51. 51, this one used to be, was it 75? This is the other really hot one, 43. 43 is quite acceptable in the radio. This one here, it burned up sometime in the past during some conflagration, it's not even showing up. This one here, barely showing up, is it? 41. 41. And there's one more up in the back here, not even showing up. What about down here in the power supply? Let's take a look here. So first, now we have the resistors here, which were getting hot. A little bit too hot. They're not anymore. That temperature there is 4950. 50 on that big lug there. 50 for me personally. 50 is about the highest temperature I can put my fingers on and not get burnt. 50? That's 50? There's no way that's 50 degrees. That's just, there's no way that's 50 degrees. 40 degrees. Where did I get 50 from? So it looks like the little resistor is hotter. It's hard to see in the camera now. There's a little green one in behind there. The big one and the green one are in series. The little green one's a little hotter. The little green one is running around 50, but the big one in the front, 40. Beautiful. I think this has worked. I think this has solved the B+ problem without introducing a big hum or any other difficulties. I really think it's worked. Great. So okay. I'm a little beside myself because that worked. I'm going to, I think, the next step, what should the next step be? It could be align the radio one last time, like do a proper alignment on it. Or hook up the amplifier and everything. You know what I'm going to do? I'm going to do the alignment next. I may post this as a separate short video just about the power supply and keep the power supply work I just did and the alignment I'm going to do separate in video. So fantastic. Oh, you know what? I got to clean up. I got to clean up and solder that spot up down here. So let me do that. Okay, so I've cleaned up the excess resistors down here, and remembered or realized I hadn't measured the B+ on the 45s, which is of great interest. So let's do that. I'm going to run the set again. Always with the dim lights at first. All is well. Now the headphones here. Let's just make sure everything's working. So that's the radio you're hearing. Okay, we won't listen to it. Okay, B+ as tested previously, right here. Again, 250, 123 volts on the radio. Now, plate of the 45. Is it this one? Would appear to be 200, as opposed to 240, as opposed to 4, I can't remember, it was crazy high before. 200. Let's just check the other one. Should be the same. 200. Greatly reduced. The good thing about that is with the reduced B+, the 45s are not going to work nearly as hard. So everything here is not working as hard. B+ comes down, all currents are relaxed throughout the radio. Consequently, the output of the power supply is down, these resistors aren't so hot, everything is cooled off. I'm a pretty happy guy. You know what? For a guy who's sick, I'm feeling pretty good now. I'm glad I came in here. So let's just turn this off now. So that's it for today. That's a big solution. Not it for today. I think I'll be in here later doing the alignment, doing the final alignment. But great. Wow. Okay. You know what? This has bothered me right from the time I discovered the high B+, right till this moment. So fantastic. Thanks a lot for watching the series so far, and I think we're nearing the end here.